Hi there, welcome back to the series. In this final chapter of Episode 5, we'll explore the concepts of hazards, combat, and enemies. We'll look at creating some environmental hazard tiles that damage and stagger the player on contact. We'll create enemy objects, make them move back and forth, and place some enemy spawns around the map. We'll look at the player's main attack in the game, and at the end, we'll even add a scripted boss battle. Here's how we implement simple hazard tiles that cause the player to stagger and take damage, adding a basic layer of challenge to the gameplay. We can duplicate and make as many of these hazards as we want. Each hazard tile is an Area 2D collidable node. Each one contains a sprite, its collision shape, and a light occluder. These hazard nodes connect to the main code using the body entered signal. Here's the simple code that runs. When a body such as the player character enters the hazard area, it takes 1 damage. Note here that we should probably be checking that this body actually has the damage function we're calling, otherwise an error is likely. For now, we'll assume it always has the take damage function. Taking damage, if you recall back to earlier episodes, causes the player to enter a temporary stagger state. In this case, the player character is pushed back and away from the hazard tile while taking the 1 damage. During this window, they cannot take additional damage and they have no control over their character's movement. Taking damage and being staggered happens in other ways too. Another common way for the player to take damage is a collision with an enemy. Let's look at an oversimplified enemy. This little monster doesn't think much, it just moves horizontally until it hits a wall and turns back around. The enemies in the game are barely enemies. They're actually kinda cute. But these little guys can damage the player if they're touched. This causes the player to stagger like normal, making them an additional challenge when paired with other platforming puzzles. We start with a new scene, the enemy scene. It has its own script and several child nodes that hold stats, a sprite, and a collision shape. In this enemy scene, we focus only on the features that are important to our little moving monsters. This will keep the code more organized and make it easier to understand by separating the enemy code from our player and level code. Let's look at the 3 scripts for the enemies. We'll check the enemy stats class first. This uses the same signals that we used for the player stats class back in episode 4. This class gives the enemy a health pool, as well as the required functions to heal and take damage. Using a component class for stats like this allows us to more easily add new types of stats, like a mana pool or ammunition count, later in the game design process. Those signals and functions will be used by the next class. This is the enemy base class based on the Area 2D node, and it contains the bulk of the logic to control health, damage, and collisions for the enemy. In the ready function, we see how the stat signals are connected, and we can see the various functions that will be called when those signals are fired. These enemies can collide with 2 different types of objects, bullets and the player. If a bullet touches an enemy, they'll take damage. If a player touches them, the player takes damage and is staggered back. The final class is the enemy class, which extends the enemy base class. This is the class that will go into our level scene for each of the enemies we want to create. It gets all of the features of the enemy base class, like damage and collision handling, but then it also keeps track of the direction the enemy is moving, and allows it to turn around when it hits a wall tile. And that's it for the simple moving enemies. Those 3 scripts control the life cycle and capabilities of a single enemy. Now we just need to create some enemy nodes and place them into our level scene. To keep the node tree organized, we grouped all of the enemy nodes together under a single enemies node. We also nest them in a simple node 2D containers where each spawn point holds a single enemy node. Later, we could use this to respawn enemies or spawn multiple enemies from a single point. So now we have 4 enemies in the level, and we can add more anytime. Besides just jumping over enemies to avoid them altogether, there is another way that the player can defeat the challenges that these little monsters present. The player will get a pistol during the course of the level. That gives them the ability to fire projectiles which, when they hit an enemy, will cause the enemy to take damage and possibly die. Let's look at the player's projectile logic in more detail. With the pistol equipped, the player can use the gamepad to fire their weapon. For now, the player can fire simple projectiles that will only move horizontally. We can add more directions later. We'll also set it up so that only 1 bullet can be active at a time, and we can change that later as well. The bullet scene is the node for the player's bullets. Like other scenes, it contains a few child nodes, mainly a sprite and a collision shape. The bullet class script is where we'll handle all collisions by the player bullets. It will also only allow one bullet to be active at the same time. It extends the Area 2D projectile class that defines the core properties and handles the main physics for all projectiles. These include properties like the bullet's speed, its damage value, and the direction it is heading. The player script is responsible for firing the bullet in the direction the player is facing. We preload the bullet scene and instantiate new bullets as needed. When a player bullet collides with a wall, the projectile will be destroyed. If it hits an enemy, the enemy will take damage and possibly be defeated, and the projectile will be destroyed. It'll also damage the boss. Speaking of the boss, the simple enemies so far don't fire projectiles of their own, but the boss will. Let's finish up by looking at the scripted boss battle and how it differs from these normal enemies. The boss consists of a bunch of parts working together to provide a more complex battle for the player. It's still a very simple example, and there are many ways that we can improve it later. Since we just covered the player projectiles, let's look at the enemy bullet class first. This enemy bullet class is very similar to the player's bullet class, except it's used by the custom boss script instead of the player script. We'll see that boss script in a moment. The enemy base class handles collisions between the player and the boss's breath weapon. If the player collides with an enemy bullet, they'll take damage. The class extends the same projectile class that we just talked about and has the same basic physics properties like speed, direction, and damage. When we look at the boss script in a few seconds, you'll see how we make the boss fire their breath weapon. The physical shape of the boss consists of several collision shapes all combined together. These boxes are overlaid over the boss sprite. Next, we'll use an Area 2D to cover the entire boss zone. The zone uses a simple script with collision signals from this area to trigger the boss script events and activate the boss battle music. We'll store the boss health in a stats component just like we do for the other enemies. And here we'll set its max health to 50. This boss area also has a UI panel and a label so that we can see the boss health. In many games you wouldn't see the numbers here, or maybe you'd see a big health bar across the top of the screen. Now that we've looked at the building blocks of the boss battle, let's look at the script that pulls it all together. First, we preload the enemy bullet scene, and we'll create duplicates of this whenever the boss is breathing fire at the player. In the physics process, we check if the boss zone is active and if we should start or stop the boss battle music. In the ready function, we'll connect a timer on the boss breath weapon. Each time the timer times out, it'll cause the attack function to be called, where we'll pick a random angle to fire and instantiate a new enemy bullet. If the player collides with the boss, they'll take 5 damage instead of the normal 1 damage that a regular enemy does. We also handle the player doing damage to the boss using their pistol, and destroying the boss encounter after the boss reaches 0 health. And when we put it all together, it looks like this. It's not the most satisfying boss battle in the world, but it's more engaging than our regular enemies, and it is a bullet sponge. We can definitely improve on it over time. In episode 5, we worked our way through the core building blocks of creating the level scene in a 2D platformer game. Starting with the foundational elements of the tile map in the tile set, incorporating basic lighting and shadows, and playing audio to bring game world to life. As we progressed, we introduced dynamic player triggers, from simple interactive switches to power-ups and item pickups, and concluded with the exciting addition of hazards, enemy spawns, and now a boss battle, all enriching the gameplay experience for our demo game. I hope you found this episode helpful. In episode 6, we'll outline a number of potential features for a hobby game developer to experiment with in their own Godot projects, from new weapons, player triggers, and enemies, to advanced concepts like room transitions and leveling systems. We'll also talk more about concepts of coding standards, source code control, and using resources in Godot. It's all about unleashing your creativity and exploring the possibilities in game development. Thank you for watching, and see you in the next video.